Piecewise functions continued. All right, so we graphed this one, example 2, and it was split at the y-axis. This one was less than 0, and this one was greater than or equal to 0. So we could use the y-axis to determine which direction to graph and keep that separate. This one is going to be x less than -1 or x greater than or equal to -1. So you can see here is the y-axis again, and I've highlighted everything on the left. So the top function where it says x less than -1, I'm only going to graph this in the highlighted part. Okay, so let's get started. This one is a linear equation. So it has a slope of 1 and a y-intercept of -2. All right, so a y-intercept of -2. So this is where I start to graph this function, but I'm not actually going to put a point here because you can see it's not in the highlighted region. So I'm going to use my slope of +1. So I'm going to go down 1 and back 1, and I'm going to put a dot there. It doesn't matter if it's a closed dot now, because even though this is open, it does matter. Hold on. All right, as soon as I said that, I knew it was wrong. Okay, so this is x less than -1. So at -1, it does have to be an open circle. So I erase that dot, and I'm going to have x minus 2. So I'm going to go down 2. I can't put a spot here, but I'm going to go down and over, and now I need an open circle. I need an open circle for the very reason that -1 is not included in the domain here. All right, I need to go down and over because this one has a positive slope, so it should be going uphill. When there's no number in front of the x, you can assume it to be a 1, so you know that's rise 1, run 1. All right, I'm going to graph my line now. So this is my first piece of the function. And then I'm going to graph the second piece of the function. So this one says if x greater than or equal to -1. So you can see this one has a slope of 4 and a y-intercept of 0. So we know there's a point here. We can put, well, let's see, get back to my pen. I can put a point here, but I need to go all the way as far as x greater than or equal to -1. So I'm going to use my slope. I'm going to have a positive 4 slope. So I'm going to go 1, 2, 3, 4, rise 4, run 1. 1, 2, 3, 4, rise 4, run 1. But I also need to come down 1, 2, 3, 4, and go back 1. And I'm going to have a solid circle here. Pretend like that's a solid circle. That is a closed endpoint. There we go. It's a little better. All right, now I'm going to take and make a line here through these points. And you can see that even though these two dots overlap because this one's open and this one is closed, it is still a function. And that's what we're looking at, piecewise functions. So all of these should be functions. The vertical line test is an easy way to determine whether it makes sense or not. If it's overlapping, you would know that it would not be a function. Maybe you did something wrong. All right, now it also says describe the domain and range again. All right, the domain is your x-axis. So what's it doing to the left and what's it doing to the right? Well, to the left, it's going forever. And to the right, it's going forever. That's what the arrows mean. And it does include -1. So it's all points again. So it's -infinity to infinity, all real numbers. And our range, this time it's going, our range is our y values. So what's it doing going up and down? It's going down with an arrow and up with an arrow. So this one will have a range of all real numbers as well. So -infinity to infinity represents all real numbers. All right, and then our end behavior again. All right, in behavior, so we always start with our x's because we've got two directions, to the left and to the right. All right, If we go x's to the left, we're going towards negative infinity. So what is the y's doing? As x goes to the left, the y's are going down. So the y's would be going towards negative infinity. Because again, this is 0. Going up would be positive y's. Going down would be negative y's. And because it has an arrow, that means it's going down forever. All right, the next one says, what is x as x approaches infinity? So as x goes to the right towards the positive numbers, what is y doing? It's going up. So y is going towards infinity. All right, example 3 says writing a piecewise function. Write a piecewise function represented by the graph. All right, so to write a function, we're going to start with f of x. This one has 2 pieces. So we know we're going to have 2 pieces, and we know that we can start with defining the domain. So let's look at the left. It's going to be all x less than 0. So this is going to be x less than 0. And on the right side, it's going to be x greater than or equal to 0. So x greater than or equal to 0. All right, so that means we're going to look at the left side, or the left side of the graph. So we're going to look at this piece first, and we're going to write an equation for it. It's a line, so we can always write a line in slope-intercept form. All right, so that means I need a slope and a y-intercept. Well, we can see it crosses at 3. So our y-intercept is 3, and we can see it rises up 1 over 1, up 1 over 1, up 1 over 1. So it has a slope of 1. So it's going to be x plus 3. And that's for all x less than 0. We've already put the domain on here, the stipulation of where it's graphed. All right, the other side has a y-intercept of -1, and it rises 2 over 1. Rise 2, run 1. So it's got a slope of 2 and a y-intercept of -1. And that's all it takes to write a piecewise function, is to piece those together, and we just use the brackets to show that these 2 pieces create one function here. All right, we have another self-assessment. This is the best way to see if you understand what we're doing. This one has 3 pieces, so that means you're going to have to define 3 parts of the domain, and for each part of the domain, you're going to have to write an equation that represents that line. All right, so please pause the video, take a few minutes, and write a piecewise function, and then come back and check it to see if you know what you're doing. All right, hopefully you took a few minutes and looked at this. So you can see that this one has a rise over run. It has a slope of 1. So if you continue till you get to the y-axis, that's where the y-intercept would be. It would cross at 2. This is 1, this is 3, and this line would cross here at 2. So you're going to have a slope of 1. So 1x plus 2. Remember, if you don't put the number there, it's assumed to be a 1. So this is the simplest way to write this function. And then that's for all x's less than or equal to -1. So you can see this is your x-axis, and the furthest this graph goes is at -1. All right, the middle piece you can see goes from -1 to +1. So from -1 to +1, 2 open circles means it is not included. So less than, strictly less than. So the x is between -1 and 1. This one is a constant function, so there is no slope. Okay, so it's just 2. F of x equals 2. So this line right here, f of x equals 2 for the domain -1 to 1. All right, the last piece of the function, and we usually always do these from left to right because we read from left to right, so we look at the graphs from left to right. So you noticed I've started here, and then I went to this piece, and now I'm on the right side. So if you come down 1 over 1, down 1 over 1, you can see the slope is -1. I know it's negative because it's going downhill. And if I go up 1, back 1, it's also going to hit at 2. So I've got a slope of -1 and a y-intercept of 2. And this one's going to be for x greater than or equal to 1, because you can see on my x-axis, that is where it would be. The furthest part of that graph is at -1 with a closed circle.